This is Math, Chapter 1, Lesson 5. So it's 1.5, and we are learning target is to graph ordered pairs in a ratio table to solve problems. So remember with ratios, it's comparing two things. All right. So we're going to have some tables here. We're going to compare two things. We're going to graph it, and we're going to see what we can learn from it. This whole idea is to interpret data, to understand what does it mean, so that when you have a question, someone asks you something, say, well, looking at the table, graphing it, it will tell me this. Okay? Math is always about, like, what does it tell you? How can you interpret the data? How do you understand it? How do you make sense of it? So, 1.5, learning target, graph ordered pairs in ratio tables to solve problems. So over here, first thing you need to remember, and I'm sure you know this, you have graph. This is a graph. Right here you have the 0 point, and then this way is x. X is the bottom of the graph, x, and then y goes up and down. I always think of when you're making a, X marks the spot, like it's out, here's the ground, here's where it is, X, on the ground. So X is this way. A Y, if you look at a Y, it kind of looks like it's this way and then going up. Like a Y goes up. So with the Y-axis, it's going up. The X marks the spot, right here on the ground. X here, Y here. Now, XY is always like this. X is always first. And the reason why it's first is you start here, and you're going to move this way or this way. You're going to move on the x-axis first. It's kind of like a ladder. You would never go up the ladder first and then move it over. That would be dangerous. You move the ladder over to where you want it, and then you go up. Okay? So, same with XY axis. You do your X first, and then you go up on the Y. So XY. X is first, Y is second. All right. So let's look at this thing right here. We're going to graph these ordered pairs. There we go. We're comparing two things. That's a ratio. Hours to dollars. Okay? I work 1 hour, I get $5. I work 2 hours, I get $10. I work 3 hours, 15, 4, 20. So I'm getting, for every 1 hour, I get 5. It's a ratio. 1 hour equals $5, 1 to 5. Now, I'm going to graph that. This first column, the first one, is the x's. This is the y's, x, y. So my ordered pair for this is 1, 5. So 1, I go over to 1. Now, on a graph, it doesn't necessarily have to be 1, 2, 3, 4, 5, 6, but it does have to be even. So if you say from here to here is 2, then the next has to be 4, 6, 8, 10. If this would be 5, it'd have to be 5, 10, 15, 20. If it's 10, it's 10, 20, 30, 40. Okay, so it just has to be equal amount of growth. So what I have here is I have a graph that's 1, 2, 3, 4, all the way on the x. And then that y is 2, 4, 6, 8, 10, 12. So now I'm going to look at it 1 and 5. 1 on my x is right here. And then I go up to 5, which is halfway between 4 and 6. So I put a dot there. That is 1, 5. Next one is 2, 10. 2, and I go up here to 10, right there. Next one is 3, 15. 3, 15. Okay. And then I could connect the dots, and I can kind of see how it's going, the line of the graph. So I took my ratio, hours to dollars, x, y, put them in ordered pair, graph them. All right? So you should be able to do that. You should be able to graph ordered pairs. Now, if you have two tables, you can use the graph to compare. to see what's happening to one person more than another. Okay, so on here we have Bob's scrapbook and Amy's scrapbooks. And they have a certain number of pages to photos. So for Bob, on one page he has 4 photos. And that's the ratio, 1 to 4. Because with 2 pages he now has 8. With 3 he has 12, and 4 is 16. It's the same thing. Okay? So the ratio is 1 to 4. Now, Amy's scrapbook has 1 page with 6 pictures, and that's her ratio, 1 to 6. So 2 to 12, 3 to 18, and 4 to 24. So we have this data. We have Bob's scrapbook, Amy's scrapbook. Okay? Now we want to see where it fits on this graph, and then maybe interpret a little bit what it means. Okay? So let's do Bob's. We'll do Bob in let's do Bob in green. Bob in green. Okay. First one is 1 and 4. 1. Now I have by 3s. So I have 3, 6, 9, 12, 15. So I'm going to have to kind of guess where it would be. 1 and 4 would be about like that. 2 and 8 would be about there. 3 and 12, 4 and 16, about like that. Now, I didn't draw this graph excellent. I mean, it's kind of just by hand, but you'll get to see the point. Okay, so we'll connect those. Now let's do Amy's in red. So we get here. 1 page equals 6. 2 equals 12. 3 equals 18. And 4 is 24. Okay. So it's going to go like that. What you can see, you know that this down here, this x-axis, your x is pages, and this is photos. The y. Oh, that was nice. Y. Gotta be careful how I make those. So what you can see here, you can interpret the data. The red one, which is Amy's, is going at a much steeper incline. So it's going higher quicker. So what that means is the pages increase, she's going to have a lot more photos than, say, Bob, who is going more like this. Okay? Pages will increase, photos not quite as fast as Amy. Which makes sense, because Amy's doing 1 to 6. Her ratio is 1 page for 6 photos, and Bob's is 1 to 4. So you can use this visual to interpret some of the data that is here. All right? So that is how to graph ordered pair in ratio tables and to solve problems.